All right, sorry. Zoom kick us out. Let me share again. People say data is power, but I really prefer this one slide saying data is the new oil. So what does it mean, data is the new oil? You look at how we process oil, you need to be able to dig the oil out, right? So you have to extract the oil, you have to refine it, and during the refinement process, you will be able to generate byproduct, and you will be able to use the oil eventually for something good or bad. So the same thing as we are processing data, when you start to collect data, you want to extract information from data. You want to clean the data because data can be noisy. Once you clean the data, you can integrate the data with other types of data. Then we can run algorithms to extract useful knowledge from the data. So in data mining, to be able to extract knowledge from your data, the data needs to be stored, managed, and analyzed. And this class, this semester, we are going to focus on analyzing data. But these three steps are very, very important. It's actually a part of this class. It's just we don't really focus on storing and managing. All these three steps is called together, they are called the big data life cycle. So what does it mean data has to be stored and managed before you can analyze them? Anybody?
When I see stored and managed, I like to think of that how information from social media, how it's unstructured. I imagine that in some type of data mining or data science stack that we wanted to get some value from that data, that we'd have to imagine solutions to take that unstructured data and store it somewhere, maybe to optimize for our analysis.
Okay, so then what is managed?
I like to think of designing database policies to, again, optimize the storage and access of the data.
Right, right. Okay, yeah. So you were right. But to talk about storage, we need to think about how we handle data sets that are really large, right? So if you only have small data set, it doesn't really matter much. But when we start to have different types of data, like you said, social media data, unstructured data, we can have data as image, we can data to be latitude and longitude coordinates. So how do we store all these different types of data? Are we going to put them on an external hard drive? Are we going to use a database? How do we do it? Right, so storage is one very important step, and it's usually handled by data engineers who design the architecture that will be able to store the data. But once you store the data, what does it mean you have to manage the data? Well, our life is already pretty busy. Who wants to manage the data? But to think about a really common data set that everybody's producing these days. Everyone has a cell phone. If you take one photo a day, that will be how many photos a year? 365. But if you have 10 photos, you have 10 times of files.
Right.
And if we want to pick a storage method, we can do, say, we just store the photos in folder, right? And when you have hundreds of photos, it doesn't really matter. You doesn't really see the difference. But when you start to have 10,000 photos in one folder, your operating system will start to complain. It will become very, very slow. So then you have to come up with method to manage your data, manage your photos so that they can be accessed very efficiently. So think about this. What does it mean you want to access your data? Right. So from our example, photos, you might want to access your data by searching people's face. You might want to access your data by searching locations of the photo. So different access method will require different management system. If you want to access photo by location, that means your management system needs to be able to read the metadata of locations from the photos, right? If you want to be able to search your photo by human face, your management system needs to be able to recognize people's face. So that's data management. Then once you can efficiently store your data, manage your data so that people can access them efficiently, we can now analyze the data. So this course is mainly focusing on analysis, but data storage and data management are also very, very important in terms of data mining. So when you hear people talking about data storage, data management, and data analysis, these three things are usually called the big data life cycle. And when we talk about data mining, we very often look at big data. So some people will go the extreme to say, all right, data mining is just a form of doing statistics on large data set. And also people will say, all right, data mining is predictive analysis or data science. So if you're in the data science program, I'm sure many of you are in the data science program, data mining, this data mining course is a very critical course and the skills that you should know. All right, so what is data mining? Given lots of data, we want to be able to discover patterns and models from the data, and the patterns and models should be valid. For example, if you have new data set comes in, your model should be able to tell you with some certainty. What would be a good example? Let's say if you build a model that would be able to process all the historical stock price, and you say, my model will be able to make some prediction for future stock price, right? And when the new data comes in, your model is making prediction. That means your model, if your model is valid, that means at least your model would have an accuracy of prediction more than 50%. Well, up or down, right? If you do a random guess, it's 50% chance you get it correct, 50% chance you get it wrong. Your model or your patterns needs to be useful. That means you should be able to act on the item. And this part, the second item is very important. Many people ignore this, but let me give you one example. So in this semester, we are going to talk about recommendation systems. So you will be building recommendation systems. So what does it mean, a recommendation system? If you're using Netflix, using Amazon, you should be able to, well, you are already a user of a recommendation system. When you log in, Netflix will say, based on your profile, we think you like this movie. Okay, so that's a recommendation system. What would be the not so useful recommendation? Anybody? Well, a useful one, let me give you one example, would be Netflix telling you that here are 10 movies, you might like them, and I rank them for you, right? A not very useful example would be Netflix telling you, hey, here are 1,000 movies that you might like, and I cannot rank it for you. So you have to go through that 1,000 and to really find out which one you like. So in that scenario, there's no way that you will be able to act on the item except going through them one by one. So it's not very useful. Your pattern has to be unexpected. That means it has to be non-obvious to the system. So it's quite straightforward. It has to be understandable. That means your humans will be able to read the pattern and understand the pattern. So the last item here, understandable, is quite different from all the mainstream machine learning models right now. People usually criticize machine learning models are black box. You have some data input, it generates some output, and you don't really know why. But in doing data mining, this for all the topics we are going to cover in this semester, many of the things are explainable. You will be able to explain the pattern to your stakeholders, and you will be able to present your findings and explain what's going on. Okay. All right. So data mining tasks. So there are two typical data mining tasks. The first one is descriptive. Wait, let me admit people. So just make sure when you join the class, you're using your USC ID and password. If you're using your ID and password, I don't have to admit you. All right, so two types of data mining tasks. The first one is descriptive method. The second one is predictive method. So what does it mean, descriptive method? Well, in the descriptive method, we usually are looking for human readable patterns that can be used to describe the data. So one example is clustering. If you look at the slides on the right side, you have a bunch of data points. And based on these data points, we want to be able to put them into groups, which means clustering. So our goal is that all the data points within a group will be similar to each other. The data points that are in different groups will not be similar to each other. Okay, so if you look at this chart, how many dimensions are we looking at and how many groups do we have? Well, okay, somebody says 5 groups, 2 dimensions, 2 dimensions, 5 groups. All right, so that's not a correct answer, and let me tell you why. The reason why you're looking at 5 groups is because of what? The color, right? That's the only clue. So if color is used in the clustering decision, that means how many groups, how many dimensions you have. You have X, you have Y, and you have color, right? So you have 3 dimensions. If you're only looking at 2 dimensions, X and Y, you have 1 group because they are all big, large blob. So this is also very important. This is also a very important thing that I want you to know before we go on. So let me use the whiteboard. All right, so many of you should already know this, but just in case, a few things about data mining that we're going to talk about, well, terminologies that we're going to talk about for the entire semester. So always when we talk about data mining or computer science algorithms in general, I want you to ask, what is the input? What is the process? And what is the output? Okay. So in our previous example, clustering, what is your input? Your input is a bunch of data points. What is your process? Your process is clustering algorithms. What is your output? Your output is clustering assignment. Okay, but what exactly is a data point? So in computer science, well, in machine learning, data mining in general, when we talk about data points, we are talking about something that will be able to describe some entities that you are interested in. And remember, we always start from 0 because this is computer science. All right, so D0 to Dn minus 1. So if you're doing data mining or you have collecting data for, let's say, students, each data point is describing a student. So your D0 is student 0, D1 is student 1, and so on. And you have n data point. Okay. And in this case, when we talk about dimension, each of your data point is represented by a feature vector. Feature vector. So your feature vector would have a length. For example, if we are talking about student, we say, all right, to describe a student, we have GPA, we have the student's age, we have the student's department. So for your D0, you have GPA 3.2, you have age 19, department CS. Okay, so now how many dimensions you have for your data point 0? 1, 2, 3, right? So you have 3 dimension. That means the length of your feature vector is 3. And each of this is called a feature component. Every data point will have exactly 3 dimensions. So the same feature component. D1, you can expect that the first column is about GPA, second column is about 19, the third column is about department. So this is not a set, not a set. That means you cannot randomly switch the order of your feature component. So in our clustering example, your input is this data points, and based on what we have seen, if you say we have 3 dimensions, that means your first dimension is X, second is Y, and then you have a color, right? So you plot it on a 2-dimensional plane. You say this is X, this is Y. You have a point here, 1, 1. You say this point is D2. So this is 1, this is 1, and color is white. Are we good? All right. So this is the basic terminology that we are going to use. But very, very important, always, when we talk about an algorithm, always think, or you can ask, always think about what is the input, what is the process, what is the output. All right, so in the clustering case, your input looks like this, right? Your D2, so D2 is here. And your clustering algorithm is going to take a bunch of this D vectors and generate clustering assignment. So what's your output look like? Well, your output could look like this, right? You will say D2 cluster 1, D3 cluster 1, D4 cluster 2, and so on. Okay, very simple output. So always think about your input, your process, and output. Let's go back to the slides. All right, so that's a descriptive method. You take all these data points and based on your data points, you identify patterns. We also have predictive method. Predictive methods, you have some data, you can use the data to learn. a model, and then you use the model variable to predict for the unknowns or future values. So like a recommendation system. You have some user profile, and you use the user profile to be able to learn how to recommend movies, books, and other items to the user. I see there's a question in the chat. Isn't the output of C1, C2 the color? Yeah, my bad. I use C again. It can be confusing. The output is just a label of the cluster. So it doesn't have to be C1. All right, so a risk with data mining is that you can actually discover patterns that you want if you look hard enough. However, you always want to make sure that you have enough data for it. You don't have data to support the findings, you might find very, well, random patterns or not very useful patterns. And we are going to look at one example. So here is that example. So in this example, I'm going to show you a very simple data mining work. The problem is we have 1 billion people. Let's say you work for some secret agency. You are tracking 1 billion people. And we want to be able to find suspicious pair of people. We say, all right, these two people are suspicious. We want to be able to question them, right? So that's the problem. But you do have 1 billion people. How do you do that? You cannot really randomly choose any two people from that 1 billion people and question them, right? So we need to have some hypothesis about suspicious. So here's our hypothesis. We say, if in our database, in this 1 billion people that we are tracking, if a pair of unrelated people at least twice have stayed at the same hotel on the same day in the past 3 years, we say this might be suspicious, right? Because they are not related as far as we know, but they stay in the same hotel on the same day twice, something might be wrong. And we want to ask them questions. So let's look at our data. In our data, we have 1 billion people. That means we are tracking 10 to the power of 9 people. And we are looking at data sets of 3 years. So that's 1,000 days. Okay, so far so good. Yes, no. Each person would stay in a hotel 1% of the time. So roughly estimate, well, if there's no COVID, this is probably pretty normal. So 1 day out of 3 months. And because of our assumption here, we should also monitor enough hotels to be able to hold 100 people. So you will have 10 to the power of 5 hotels. So this number of hotels will be enough to hold 1% of a billion people who visit a hotel on any given day. Okay, are we good? So these are the basic assumptions and the data we are collecting. So if everyone behaves randomly, would our data mining or our data mining assumption tell us anything or detect any suspicious? So let's look at the math here. 1 billion people, 1,000 days, 1% of hotel stay, 10 to the power of 5 hotels. The probability of any two people both decided to visit a hotel on a given day is 1% times 1%, right? Because we have this assumption that's 1%, and 2 people independent, so it's just 1% times 1%. So it's a tiny number. The chance that they will decide on a day to stay in a hotel is pretty small. The chance that they will visit the same hotel for 1 day is this probability we just calculated divided by the total number of hotels, right? Because when we were calculating this probability, we say it's any hotel. So the probability is now even smaller, 10 to the power of minus 9, and we are talking about a hypothesis for 2 given days. So 10 to the power of minus 9 times 10 to the power of minus 9, this is 10 to the power of minus 18. Very, very small number. Great. Probability is very small. Why do we want the probability to be small? Well, because if the probability is large, that means our hypothesis does not really work, right? We're looking for suspicious people. That means we are looking at abnormal activities. So this should be rare activities, and the probability of this activity to happen should be very small. So good, it's very small. Well, however, so far we talk about any 2 people, any given day, right? We fixed the hotel, but still any 2 people in any hotel. So how many pairs of people do we have? Well, if we're looking at 1 billion people, it's 1 billion choose 2, right? This is the number of pair of people that you would have. So for 10 to the power of 9 choose 2, because this is a large number. If you look at here, for large n, we will just take an approximate number. It's n squared divided by 2. So 10 to the power of 9 choose 2 becomes 5 times 10 to the power of 17. So that's the number of peoples that we can have from our data set. Great, we fixed people. We fixed hotel. Now we just need to fix days. How many pairs of days we have? Do we have? We are tracking 1,000 days, and we say 2 days, right? So that would be 1,000, choose 2. And because 1,000 is a large number, so we just use an approximation. So that's 5 times 10 to the power of 5. All right, so we have all the numbers we need. What is the expected number of suspicious pair of people? This is the number of pairs of people we're tracking. Number of pairs of days we are tracking. And a tiny, tiny probability for them to be suspicious. And you come up with this 250,000 pairs of people. So is this a good result? Do we detect anything that's useful? Well, it's actually not quite useful, right? Our goal is to be able to find a small number of pairs of people so that we can question them. But now you still have a large number of people, pairs of people, and you do not give me any ways to rank them, right? How do I start? I have to go over all these numbers. So this is not a really good hypothesis, although all the calculations are correct, but we still need some additional evidence to help us either. Well, okay, let me ask you this. What is the input here? Your input is people, hotel, their stay, and all the days you're tracking, right? So all this data you have. And the process is very simple. It's what we have been calculating. And what is your output? Your output is a list of 250,000 people. How do we improve our output? Well, I can see two ways. One is you can make this number smaller, right? You say, all right, instead of having 250K pairs, now we have 100 pairs. Oh, 100 is probably much more easier to deal with than 250K. What would be other options? Without reducing this number, how would you be able to, what would be the output that will make this hypothesis more useful? Well, you can have ranked result, right? It doesn't have to be, it can still be 250K, but at least you can rank them and you say, all right, the first one here, it's 100% suspicious. How do we know? Well, we can do any other things, right? We can say every hotel has a suspicious number based on the surrounding of the hotel, based on the time they check into the hotel, and based on that, we will be able to score each of the pairs. And you maybe have somewhere here 50% when you are reaching 100K pairs, right? So a human then can work on this list from the top and to start to see if any of the pairs are really suspicious. So when we are working, okay, all right. So that's an example of not so useful data mining result, although our hypothesis seems valid and the process seems okay. In dealing with data sets, we are facing different types of challenges. We are going to use different types of data operators. We are going to handle different types of data modalities. So let me quickly give you some ideas about all this here. And we are going to go into the details of them when we are at each of the topic. All right, challenges. When we start to use data, you will need always to think about what exactly is the usage of your data. And based on the usage of the data, you will be able to think about, all right, so if our goal is to be able to predict traffic, then missing some data set might not be that important, right? But if our goal, if our usage is to track a precise location of a vehicle, then you don't want to miss any data. So usage is important. Data quality is very important. Another example for data quality is, well, in addition to missing data, is location data, right? If you have cell phone data, it gives you a latitude, longitude point on a two-dimensional map. But if you're in an urban area, this point it doesn't really represent your real location. It's usually have a buffer. It says, I think this person is here, but I'm not sure. Maybe this person is 3 feet within this buffer, right? So that's the data quality. And the context of your data, how did you create how did you collect the data? What is the other data set that you can use to help you augment the data? So remember our example for the hotels. Each hotel would have a location, but you can actually base on the hotel surrounding to give the hotel a suspicious rank. Or you can use people's check-in time to give this check-in history a suspicious rank. So that's the context, but often you need to use additional data set to provide the context. We are dealing with streaming data. So these are the data that coming in can be at a very, very frequent. So for example, let's say this is the weather station. This is my house. And we have a weather station. This weather station is collecting data. So you have wind speed. What would the data look like if I open a program to read the sensor? Well, it probably look like this, right? 5 wind speed. I don't know the unit, but it's 5 and it's 12 p.m. January 21, 2021. And 4.5, 12:01 p.m. and the same day and coming in. Right. So these are streaming data. The data would the data comes in with a timestamp or with an order, and it can't keep coming in and never end. Other streaming data would be something like user query. So if you are a search engine, you have many users issue query to you, and you are taking those queries, you want to respond to those queries, right? Those are streaming data to a search engine. Scalability is challenging when you are dealing with small data sets, medium-sized data sets, and large data sets. You all need to use different data architecture to be able to manage and store the data, but you also need to have nice algorithms that would be able to scale up and process large data set. Data operators, we're talking about, you need to collect your data either from the web, from a sensor, from anywhere, prepare the data into some format, right? So for example, if you take this data in, what if there's missing data? What do? Well, in data preparation, you will, for each missing data, you probably will put a null value, right? Indicate it's missing. Then you have to represent data. So represent the data, it could be you're using a CSV file. You say, this is a CSV file. And I do not give you a column name because I assume you know. Or you can represent the data using a relational table. You say, all right, I will take all this streaming data, I will store it in a table with some column name and predefined data type. We can also model the data. That means we have some idea about the data. So for example, we say, all right, our model is very simple. Your newer value cannot be 10% more or less than your older value, okay? If that's the case, when you have a missing value, we will be able to use your older value to guess for the new value, right? So that means you have a model, you'll be able to generate some data. You might be able to reason over your data. We are going to talk about reasoning after we talk about ontology. And you need to be able to visualize your data, either using charts, maps, 3D, virtual reality, anything that might be useful for the types of data you're looking at. All right, and for data modality, we can have signals, well, usually like this, could be from a sensor, can have multimedia, videos, audios, photos, can have unstructured text, documents, websites. You can have networks. What would be an example of networks? Well, your social network, right? So you have one friend, I have two friends, and we want to base on the network or graph to be able to do some interesting data mining. Like you can cluster your social network to find different groups of people. And that's very useful. For structured data, you can have CSV files, you can have, what else? Database tables as well. And ontology. All right, so what exactly is ontology? Let's talk about ontology and reasoning, and then let's take a short break. So let me use my whiteboard again. All right, in ontology in computer science is very similar to, you can think of this as some way that people use to describe data. So for example, I can say ontology is a graph. I can say there's a pet. Pet is like a class. And we have dog, we have cat. So we'll say cat is a type of pet. Dog is a type of pet. Okay. Then we can start to do more interesting things. We can say pet stay at home all the time. Okay. So you can start to use this to organize your knowledge about something. So usually when you have ontology and you have data that's mapped to an ontology, we call this the knowledge graph. I think there's a knowledge graph course in the data science program. ISI also have a large knowledge graph center, research center. So what exactly is knowledge graph? Well, if you Google a famous person, let's say you Google Barack Obama. This is the search box, and these are the returned result. But on your right-hand side, what would you have? Anybody use Google before?
His face, and then his name, and then probably his spouse, and like different things like that. Or like he's the former president, things like that.
Right, exactly. You have some structured data about Obama, right? You can have age, nationality, president of the previous president of the United States, spouse, children, and when you click them, they will link you to other things. So this is organized by knowledge graph using ontology and data that Google can find from the internet. So in this very simple example, I can show you what does it mean reasoning. So if I say, based on this ontology, I say, hey, I have a dog. My dog is Bob. And I say, Bob is a dog. And once I do that, I can start to ask this knowledge graph. I say, where does Bob stay at all the time? So based on the knowledge graph, your computer will be able to say, all right, Bob is a dog. Bob is a dog is a pet stay at home all the time, so Bob must stay at home all the time, right? Without explicitly tell it that, hey, Bob, stay at home all the time. So this is just one way to organize your data. And you can see this is really cool, a graph-like structure. The problem is this is sometimes very slow, but it supports really nice reasoning. All right, let's take a break for 10 minutes and we will come back to the lecture. If you have any question, put it in the chat. We will be back in 10 minutes. Thank you, everybody. All right, I'm back. So there's a question. For the clustering example, the answer should be 3 dimensions, X, Y in color, and 5 groups, right? Okay, well, it depends on how you look at it. So it's just a toy example. But if you are saying we have 5 groups, then you are using the color dimension. So at least you need to have that color dimension. You don't have to have X, Y, right? You can say I have 1 dimension data. But based on that chart, you do have X, Y, and color. So we say 3 dimension and 5 groups. Okay. I hope that's clear. All right. Let's go back to the slide. All right, cool. We were here. So these are all the things that you have to care about when doing data mining. In data mining, the subject overlaps with databases. Since we often talk about large scale data, but database people usually run simpler queries. So for example, find average GPA for all the students. Overlaps with machine learning. Learning tends to work on smaller data sets, but very complex models. Also with CS, computer science theories, so randomized algorithms that sometimes take, well, always, if it's a randomized algorithm will take a randomized component. So what does it mean, randomized component? Well, like sampling, right? So if you have 1 billion people, you don't want to deal with 1 billion people. You say, all right, I will just deal with 1% of the 1 billion people. That 1% is your sampling strategy. So that's why we call it randomized algorithm. Different cultures to a database person, data mining is an extreme form of analytic processing. So queries that would be able to look at large amount of data, and the result is the answer of the query. To a machine learning person, data mining is the inference of the model and often as the parameter of the model. Let me give you one example that we are going to cover later. So for example, if you take a social network graph, we say, all right, from this social network graph, we want to be able to identify groups of people, right? So this could be groups of friends. And we already have some idea about how to group them. So we have a model. The model can be a parameter. One of the model parameter would be the number of groups. And if you can fit your data into that model, then that parameter will give you answer. The answer is 3 groups, 5 groups, 6 groups. And in this class, we are going to look at them all. So about this class. So this now becomes very important because so far we talk about in general what data mining is, but now we're going to talk about what we're going to cover in this class. So this class, again, overlaps with machine learning and statistics, AI, databases, but we will be focused more on scalability. That means we're going to work on large data sets. Algorithms, we will learn algorithms, we will design our own algorithms to be able to handle large data set and detect patterns. Computing architecture, we are going to cover MapReduce that will be able to handle large data set and automations for handling large data. We will learn to mine different types of data. So your input will be different. Your data can be high dimensional. Remember our data points example. In that example, we have how many dimensions? 3, right? High dimension means you can have thousands of dimensions. Your data can be a graph, social networks. Your data can be streaming data, so it's infinite and never ending. Your data can be labeled, so each data point can have a label like good student, bad student, good student, good student. So how do you take your data points and learn that label? we will learn how to use different models for computation. We're going to cover MapReduce real soon, streaming and online algorithms, and single machine in memory algorithms. And I'm going to talk about single machine in memory algorithms in the next lecture. So don't worry if you are not familiar with the terminology. And most importantly, one thing that I really like about data mining is we are going to solve real problems. So we are going to build a recommendation system. We are going to do market basket analysis. So people purchase item A would highly likely to purchase item B. We're going to work on spam detection, detect duplicate documents. We're going to learn different tools, linear algebra. You have to have some knowledge about it. I'm sure everybody, maybe not everybody, but if you know what an eigenvalue and an eigenvector is to a matrix, then you should be okay. Optimization, we're going to cover some stochastic gradient descent, but it's not that important in this class. Dynamic programming and hash. So how this fits together? Well, on the application side, we're going to build recommendation system, identify association rules, like people purchase item A would purchase item B. Know how to detect duplicate documents. We are going to use some of the machine learning algorithm, but not a lot. If you like machine learning, you should take the machine learning class as well. We're going to handle streaming data, so data streams, web advertising. So web advertising is actually very, very interesting, and people usually ignore it. Let me show you on the whiteboard. So what is web advertising? Today, one of the most profitable business online is ads. So if you search on a search engine, for example, this is one type of the online ads. This shows you the result. This probably show you some summary from the knowledge graph, which is good. And here you usually see something, right? So what is that? For example, if you query Toyota, this part would show you different ads. So it could be an ad from Honda, it could be an ad from Toyota, or Honda, or an ad from BMW. Okay, these are all car brands. And once the search engine show you that, and if someone click on the ads, these advertisers will have to pay Google. For example, Honda would say, all right, if somebody search Toyota and you show my ads and the user click on it, I will pay you 0.01 cents. And Toyota will say, all right, I also want my ads to be shown even if someone search for Toyota. And if the user click on Toyota here, I'll pay you 0.001 cents. Well, because they already searched Toyota, I don't want to pay that much. And BMW says, all right, if people click on my ad, I will pay you 0.005. Okay, because I think they might think Toyota, people searching Toyota will be a different customer segment. We will buy W, so not a really large number. So if you're Google, which ad do you want to show? Assuming that you can only show one ad and you have 3 candidates, which one do you want to show? Anybody? All right, so people says Honda. This is a very good answer. This is usually called a greedy algorithm because you really want this 0.01 cent, right? Well, compared to this 0.001, it's nice we have this amount of money. However, there is a complication. So every advertiser here will give you some budget. So Honda will say, all right, this month I'm only willing to pay $100. Toyota say, I'm only willing to pay 50. BMW said, I'm only willing to pay 100. Okay. So in that case, if you always choose Honda, you are going to run out of Honda's budget really quickly, right? So 100 divided by 0.01 cents. This is the number of times that you will be able to show Honda's ads. All right, we used up Honda's money. What's the big deal? Well, the problem is Honda may bid on multiple keywords, right? So Honda will bid on keywords Toyota. Honda might also bid on keywords. So let's say keywords Toyota. Also bid on keywords Civic. Toyota bids on keywords Toyota and 4Runner. Well, it's a type of car. BMW bids on Toyota and also bids on itself. So if you, every time when people are searching for Toyota, you show Honda's ads and you run out of Honda's budget, think about what would happen when someone searched for Civic. Now, when someone searched for Civic, which ad are you going to show? Well, you cannot show BMW because BMW did not bid on Civic. You cannot show Toyota because Toyota did not bid on Civic. You cannot show Honda because you already used up Honda's budget on this Toyota keywords, right? So you're actually losing money. You used up this $100, but there are 50 and this 100 that you never use. So how would you be able to build an algorithm that would be able to handle this situation and maximize your profit? So that's the topic we're going to cover. It's called web advertisement. And the tricky part is you do not know about the future, right? So at the time you see a query Toyota, you do not know there will be a Civic coming in. So how do you balance this? Let's come back to our slides. All right, so that's web advertising, query on data stream. So very often you want to be able to ask questions over streaming data. So for example, if you're Amazon, your streaming data could be instant purchase records from users. And the question you might want to ask is, in the last 24 hours, what's the best selling product, right? And that's difficult to do. Graph data, we are going to cover PageRank. That's the algorithm that made Google famous. Community detection, detect how many groups you have in a social network graph, detect spams in a graph, and we're going to handle high dimensional data with these 3 algorithms. And again, let me show you the whiteboard. So we're going to talk about all these algorithms in details, but I just want to use the time here to motivate all these algorithms that we are going to learn. So when we are working on high dimensional data, remember we already talked about this, right? D0 to Dn minus 1, and you have feature vectors to represent each of your data points. And originally we were only looking at 3 components, but this is not realistic. You can have thousands of components. So let's say we have 1 million components to describe a data points, and we have 10 million data points, right? So this becomes a really, really large matrix, and this becomes impossible to handle for very simple tasks. For example, if I want to find the most similar data points to D0, I have to compare D0 to every other point. In every comparison, I have to compare pairwise component, right? So that's how many steps we have to do. You have to do 1 million pairwise component, and you have to do 10 million comparison for only one record. That's too much. So how do we deal with this situation? We are going to cover locality sensitive hashing and min hash. So the min hash algorithm will be able to help us reduce the dimension, like all other dimension reduction algorithms. I don't know if you guys know, PCA is one of them. So instead of looking at 1 million component, you can only look probably 100 dimensions. Locality sensitive hashing will help us to reduce this 10 millions that you have to compare to a very small number, maybe 1,000. Right, so now you can take this part and still find an approximate answer to handle the data sets. All right, so that's locality sensitive hashing, clustering, and dimensionality reduction. We covered clustering already. So this semester, we have 2 TAs because we have 70 students. So Weiwei Duan and Minchen Chu, they are both computer science PhD students. They will be monitoring the discussion board and help you with your assignments. We have a grader, Manan, and Manan will help you with your quiz. We have quiz every week. For office hours, my office hour is every Wednesday after the class. If you want to talk to me, you can stay. For the TAs, they will announce their office hours and Zoom links on Piazza. And we are going to have 2 office hours for the TAs for each week. And there'll be 2 separate hours. So for example, it can be Monday from 8 p.m. to 9 p.m. Pacific time, so that if you are not in the US, you might still be able to go to the office hour. And the second office hour might be Thursday, 12 p.m. to 1 p.m. Okay. And your grader would also host an office hour to help answer questions about the quiz. So some logistics, this is extremely important. For the course website, make sure you signed up for Piazza. We are not going to use Blackboard for any discussion. All the discussion should be on Piazza. Blackboard will be used for uploading your grades, so you can look at your grades on Blackboard. Lecture slides, same day after the lecture, I will upload them to Piazza. If I don't, just remind me on Piazza. For your homework, we are going to use Vocarium. That means you're going to submit your homework to your code and run it on Vocarium, and your TA will grade them, detect plagiarism, or on Vocarium. Readings, mining of massive data sets. We're going to use this textbook. It's free online. You can find it. We don't have a version on Blackboard, but you should be able to find online from the textbook websites. They have PDF versions. We're going to use other relevant papers. Oh, by the way, for the textbook, second edition or third edition are both fine. So questions? All right, there are some questions about the quiz. Just give me 1 second. All right, so for the quiz question, we are going to have quiz every week starting next week, every Monday. If we have a quiz on Monday, if we have a class on Monday, so if Monday is not a holiday, we will have a quiz. This is very important. Let me say it again. If Monday is not a holiday, we will have a quiz. So please don't ask me if we have a quiz next week, after next week. All right. Can we have the recording lecture after the class? Yes, we can. Depends on how long does it take for Zoom to process it. And once it's processed, I will upload it. So here's another question. So what will the quiz be in the following Monday? That's okay. So next Monday, the quiz will cover everything we have discussed so far and everything in the required reading. So on the syllabus, you will be able to see the required reading. What will be the format and the duration for the quizzes? It's usually 30 minutes at the end of the lecture, and you have to turn on your camera, your TA will be there, and format would be very often you have to work on some questions. I'll talk about that later. All right, let's talk about communications first. So use discussion board on Piazza for all questions in public communications with the course staff, including me. Please do not email us. Please do not email us. Please do not email us. If you have questions, post it on Piazza so that everybody will be able to help answer and see the answer from us. And we will be working very hard to try to answer your questions within 24 hours, except weekends. The TAs would have weekends. So make sure you use the discussion board. And we will post any course announcement to Piazza, so make sure you check it regularly. You can sign up for notification. And again, do not use emails unless it's personal. Okay, so personal means you might want to, sometimes you have some difficulties in life, you want to explain it to me, you can email me, that's totally fine. But if you have questions, things like which chapter will be there in the next quiz, that's Piazza material. And I can also already tell you, the material that will be covered in a quiz is everything we covered before that quiz, either in class or on the syllabus in the required reading. So the workload for the class, for the course, we have 4, well, no, we have 6 homeworks, sorry, not 4. We have 6 homeworks, and it requires you to use Spark and Python. If you want to use Scala, we will give you bonus. So, but you need to submit 2 versions. So you submit your Python version, you submit your Scala version, then you get the bonus. Okay, so we have so many bonus in this class. Just the goal is to encourage you to learn more. So there's a question for the week before. Yeah, for the week before. All right, so 6 homework. We have MapReduce, finding frequent item sets, recommendation systems, clustering, detecting communities, and I think one more is streaming data. Okay, so your assignment will take a lot of time. Make sure you start early on your assignment. So let me give you a very brief idea about your assignment. This is time. This is now. This is the end of semester. This is the difficulty of the assignment. Here will be your first assignment, easy. Second assignment, not so easy, but doable. Third assignment is very difficult. Fourth, fifth, sixth. Okay, so make sure you time it right. And your assignment really takes a lot of time, so always start early. And you need to work on your own code. We are going to run plagiarism detection for every submissions we have in our repository. That means we are going to include codes from the previous semester, any GitHub repository that we can find online. Please work on your own code. Do not give your code to any people. You are encouraged to discuss assignments, but never exchange code. So let me give you one example. What is exactly not to do? So you say, oh, I have some problem. Someone will say, I have some problem uploading my code to Vocarium. So I use other students' machine to upload the code. And I accidentally use this other student's Vocarium account to upload my code. Okay, that's a no, that's plagiarism. We will report you. So please don't do this. There's a question for all assignments, just for individual, no group. Yes, no group assignments. And I want to tell you why I want you to do assignments. So for each assignment, we designed it in a way that you will be able to add an item on your resume. For example, this one, you will be able to say, I built a recommendation system using real data sets from Amazon containing 10,000 transaction data, and my recommendation system include the following techniques and achieve an accuracy of 98%. Okay. For finding frequent item set, you can say the same thing. You can say, I built a system to find frequent items from, I think we are also using Amazon data sets, and you can talk about the number of data set, you can talk about the result, right? So these are all very nice items to have on your resume if you're looking for a software engineer position or a data scientist, data engineer position. So for your weekly quizzes are actually just exercises. So I am a firm believer that you have to hands-on work on algorithms. So for example, we are going to cover some algorithms to build a recommendation system. I will ask you to work on the algorithm on paper in your quiz. And most of the questions are from previous years or from the textbook. The key is, even if you have a previous semester's quiz or the textbook questions, I still want you to be able to do it on paper, right? So that will help you to figure out how the algorithm works and how to come up with the solution without using a computer. So normally I see students would usually have perfect scores for their quizzes, but we will also drop your 2 lowest quizzes. So just in case you miss some of the quizzes. And in that case, we will not offer any makeup quizzes. If you, for some reason, you miss one quiz, you miss one quiz. You need to turn on your camera during the quiz. Your TA will monitor the camera, so make sure you do have a camera. We have a really difficult comprehensive exam, 70% of your grade on the last day of the class. The exam will cover everything taught in class. You also need to turn on your camera. So for the comprehensive exam, it's all multiple choices. I say difficult, but actually we do have someone scored 100% on the comprehensive exam, and the class average is usually about 70 something to 80 something. We're going to have a final project. It's actually a competition. So in the competition, you are going to take your assignment 3, which is building a recommendation system, and you're going to improve it based on all this other knowledge you learned from this class. And you need to be able to beat your TA and beat other students. It's 5%, and we have bonus for that. And we are pretty generous on the bonus. There's no final exam, and we do not curve the final grade. It's going to be a fun work, but it will be very difficult. So, okay, so here's a question. Are the quizzes and exams going to be on Blackboard? Quizzes will be PDF files on Blackboard or Piazza. I will give you the link. You download it, you write it on a paper, or you type it up. And if you write it on a paper, you take a photo, then you upload to Blackboard before the end of the quiz. The exam will be on Blackboard. April 29th is a Thursday. All right, sorry. Should be April 28th, Wednesday. All right, any questions? So I really like to do the competition. The reason why we are doing the competition is because I want you to be able to learn how to handle real data sets. You will be able to, well, you will have the opportunity to put something like this on your resume, right? Game profile, which is pretty cool. You can say, this is, I am the first place. USD data mining competition, spring 2021. And if you want me to write any reference letters, I can add that too, which is pretty nice. So previous winners, they are all having nice jobs. Be like them. Homework policy, we do not offer regrading. I find regrading really tedious for your TA, so let's not do regrading. If you are late for 1 week, within 1 week, there's a 20% penalty. If you're late more than 1 week, there's 0%. So you don't need to submit it because it's 0%. But we do have a free 5 days extension. That means you can use these 5 days on your homework however you want it until the last day of the class. So don't save it. If it's the last day of the class, you still have 3 days remaining. We cannot reimburse you. No more extension day will be given for any reason. So for example, you say, I have a very important thing that I have to do. Can I use my extension day? Yes, you can. You don't even have to tell us you have something you need to do. You just use your extension day. But just remember, once you use up all your 5 extension days, if you have other things that you need to do, there's no more extensions. You need to let your TA know if you're using these extension days when you submit your homework. So some prerequisite for this class, algorithms, you need to know dynamic programming, some basic data structure. So basic data structure is more important than dynamic programming, which we are going to cover. Basic probabilities, typical distributions, Gaussian distribution, maximum likelihood estimates, what is a moment. Programming, I ask you to use Python in your assignments, but we are going to reward you if you use Python and Scala. We're going to provide some background. Your TA is going to use 1 lecture to tell you about Spark, Scala, and PySpark, but that's it. You have to learn all these things by yourself. So the course is mainly about algorithms, not programming. This is the typical course grade. every year people would ask you, what happened if I am 93.5? And I promised that I would change the slides and syllabus, but I never remember. So if you're 93.5, you will be an A, okay? 93.1, you will be an A. But other than that, we are pretty strict on this grading breakdown. So there's a question, can we split the 5-day extension to be used for multiple assignments? Yes, you can use it, whatever you like. All right, so after the class, if you like the class, if you like our research project, you want to do directed research, you can contact me. And we do have course producer or grader positions after the class for the next time I teach the class, and paid RA positions for PhD students. If you're a master or undergrad, we have student worker positions. So to do items, after today, I want you to download the textbook, install Spark on your machine, just try it. Play with datasets, Group Lens. This is a dataset from the University of Minnesota. Group Lens, I just took the photo today just for you guys. And look at the Amazon dataset. So you will be able to see the large dataset, what they look like. Sign up for Piazza, email me a photo if your roster photo is outdated. So this is sometimes confuse me when I look at your roster photos and I cannot find you in class, and that's usually because your photo is outdated. All right, one more thing. Yeah, you can send me an email if you want to audit the class. Yeah, that would be good to know. Check with your advisor for the last day to drop a class with a mark of W, so you can still drop the class. And if you think you will not have time to finish the assignments, or you really need some credit or grades to be able to graduate, this is your last semester, think twice when you take this class. All right, if you're dedicated to work hard on this class, we will help you. It will be fun. All right, how's everybody? I hope now you have some understanding about this class. All right, there's a question. What's the user percentage of A grades students? We usually have, I think, a third of students having A. Can you repeat the part about it being your last semester? Did I say? Oh. So sometimes the student will come and say, this is my last semester. I really need an A to graduate because I have an offer from Airbnb and it's 300K per year. If I don't get an A, I will not be able to graduate. And that's not a valid excuse. The only thing that you can ask us at the end of the semester is if we made mistake on the grading. If we do, we will be happy to correct them. But other than that, you're responsible for your own grade. Any more questions? Are we good? What is GRS photo? So you have your student ID. If you look at your student ID, there is a photo. That's the photo in the USC system. That's the photo I will see. And I usually use that photo to identify people in class. I know we might not turn on your camera, but very often I find those photos not very useful in finding people. So if you look at your photo, you say, oh, this is not me, you can send me a photo of you. All right. Are we good, everybody? Can I get some response? We start by having 70 people. Now we have 65 people. Yes. Okay. All right. Good. So I will be asking you guys, are you okay in all the lectures, just to make sure that we are here. And I hope your answer will be so far so good. So the quizzes are not cumulative. Yeah, so your quiz might not be cumulative. I say might not be because sometimes I forget and I add some other materials, but you should be able to know. All right, thank you everybody. I will see you next week. Have a good weekend. Make sure you do all the things I told you to do, and you are going to have a fun semester. Work on cool assignments. Have a really nice resume. Find a good job. USC and start to build really nice recommendation system that we can really use on Amazon or Netflix. And then you can email me back. All right, thank you guys. See you next time.